Hello, AP Calc. So today we are looking at the product rule. As you can see over here, we're going to have a lot of rules in our tool belt. We are just focusing on one of them today. So our I can statement for today is I can use the product rule for derivatives. Now, before we begin, let's just take a step back and think about this. If I was given this problem, now I didn't write it out all the way, so let me rewrite it a little bit here. As of now, in order to take this derivative, what we would have to do, because all we know how to do at this point is take the derivative of simple polynomials and trigonometric functions, we would have to, distribute this x to everything in those second set of parentheses, distribute this 9 to everything in those parentheses, simplify, and then take the derivative. And I'm going to be honest, that sounds like a lot of work, a lot of distributing, and a lot of unnecessary things when we can use a simple rule instead. Yeah, ain't nobody got time for that. So here we are going to use the product rule. So as you're writing notes, you are definitely going to want to get this down in your notebook. What this is saying is it's saying, hey, I'm trying to take the derivative of two functions that are being multiplied together. And our rule says that the derivative of those two functions that are being multiplied together are going to be that first function times the derivative of the second function plus the second function times the derivative of the first. Remember that little apostrophe just means prime or derivative. So this seems like a lot, it's not really a rhyme, but a way to remember it, just to shorten this a bit, we can call this the first function and this the second function. And our easy way to remember the product rule is to say 1 d2 plus 2 d1. Oh, I should put those a little bit closer together, my bad. D, of course, stands for derivative. So here we'd have 1 derivative of the second plus second derivative of the first. I'm going to pause just for another 15 seconds just to verify that everybody has this down. Remember, as this is a recording, you can also pause if you need a little bit of extra time. All right, I think that should be enough. Again, if you need a little bit more, feel free to pause. Here we go. Before we move forward to our first example, I want to address a common mistake. Many times as we're taking derivatives, we tend to get overwhelmed and look past some of those basics. If you ever see two functions being multiplied together, we have to be careful that we're not simply taking the derivative of the first, the derivative of the second, and multiplying those together. We have to use this rule. If it is addition or subtraction, you can just take the derivative of the first and the second and add them together. You can just take the derivative of the first and second and subtract them together. But for multiplication, we have to use the product rule. And we're going to look into this quotient rule here in not too long. So without further ado, let's get into that first example. Here we go. I have two functions. Let's label this f of x and this one g of x. Those are two separate polynomials that are being multiplied together. Our problem is asking us to find the derivative of h. So this whole thing is labeled h. So our product rule, remember, I'll write it up top so we don't forget. It's the first times the derivative of the second plus the second times the derivative of the first, or 1 d2 plus 2 d1. All right, so what I'm going to do is I'm going to make myself a little bit of a key here. I'm going to write out my f of x, my g of x, and then I'm going to take the time to find both of those derivatives separately over here. And we'll get to a point where probably we don't have to do this, but for now it's a safe bet just to make sure we're organizing our thoughts. So we already determined that our f of x is 5x plus 6, and our g of x is this x squared minus 3x plus 10. Now we have to take those derivatives. So what I'm going to do is I'm going to take the derivative of 5x plus 6, which is just 5. And the derivative of g of x, again, we're using that power rule. This would just be 2x minus 3. Now that I have my key over here, I can take all these pieces of information and plug them in to my product rule. So here we go. First, which is 5x plus 6, you'll notice I'm putting parentheses. Those are essential. Times the derivative of the second, which was 2x minus 3. Plus the second, which is x squared minus 3x plus 10, times the derivative of the first, which is 5. Now from here, this just becomes a simplification process, so we now are using that distributive property. So now I can take this 5x, multiply it to both. I get 10x squared minus 15x. Do the same thing with that 6 plus 12x minus 18. And then over here, I'm going to distribute that 5 to all of those parts. I'd get 5x squared minus 15x plus 50. Now I can pinpoint some like terms. So I do have a couple x squareds that I can combine together. Make sure we're paying attention to those signs as we go through this. I also have a lot of x's. So I have this one, and this one that I can combine. So that would be negative 30 plus 12. So that's going to end up being negative 18x. And then last but not least, I have this minus 18 and this plus 50. So that's going to be 32. And voila, we have our h prime of x. Sorry about the noise in the background, guys. And we have successfully used the product rule here. All right, I have one more example for you all, and you knew I had to do it. I had to throw some trig in there. So now I have trig and I have some thetas. How exciting. Remember, thetas just like x. Our goal is to find this derivative of this function. And again, we're noticing that there are two separate functions here that are being multiplied. Now, because this one's already labeled f of theta, I'm not going to use f again. I'm going to relabel this. I'm just going to use g of theta here and h of theta. And that product rule still applies. It's still 1d2 plus 2d1. We're just going to use some different variables here. So now instead I'm going to have g of theta, h prime of theta, plus h of theta, g prime of theta. So again, I'm going to make my key over on the right-hand side. And here, we need to be memorizing these, if you haven't already, our trig derivatives. So our g of theta and our h of theta are sine and tangent. And when I'm taking my derivative, again, going back to those trig derivatives, sing that song in your head if you need to. Our derivative of sine, you guessed it, is cosine. That was the very first trig derivative we learned. On to our derivative of tangent. This one is a little bit trickier. This one is secant squared. All right, giving everybody just a second to catch up, make sure we're all on the same page. All All right, so now what I'm going to do is I'm going to take all those trig derivatives and those original functions, and I'm going to plug them in to that product rule formula that I have up in the top right-hand corner. So I have the first, which is g of theta this time, so sine of theta, times the derivative of the second, which we said was secant squared theta, plus the second times the derivative of the first, which we said is cosine. Now, if it doesn't ask for you to simplify, we can stop here. However, more than likely, it will simplify this for you a little bit. So we have to go back to some of those reciprocal identities that we learned in pre-calculus and we practiced earlier this year. Secant is the opposite of cosine. So I can really rewrite this as sine of theta times 1 over cosine squared. And tangent, I can break into sine over cosine. And you know, if what you first try with trig identities doesn't work out, just go back to the drawing board. It's not the end of the deal, or not the end of the world. I just wanted to get everything in terms of sine and cosine. I thought that would probably be my best bet so I could see what I was working with. So since I have really the sine is in the numerator, I could, if I wanted to, rewrite this as sine over 1. Let's do that, in fact. And when you multiply fractions, you just multiply the top, multiply the bottom. So really this is like having one sine on top and 2 cosines on the bottom. So I'm going to be left with sine of theta over, I'm just visualizing this for you guys. This one, our cosines actually cross off. So here we're just left with sine of theta. Let's break this up a little bit more. Now that I have these 2 cosines separated, I can kind of imagine this as 2 separate fractions, sine over cosine and 1 over cosine, which we know I can write as tangent of theta, and cosine is the opposite of secant. And again, we play around with it until we get an answer that looks like what we want. So this is kind of how I would simplify it, but there are other options out there. Give you guys just one more second, make sure we're all caught up. All right, and one more time, I'm going to go back to that product rule, just so we have it engraved in our minds. Sorry. You are going to use this on your practice today. Good luck, you all. I know you can do it. Yay.